Bioinformatics.
Welcome to Lecture 8. This is going to be my lecture on regular expressions. So I'm really excited to kind of talk to you guys a little bit about regular expressions and introduce you to them. Now this is going to feel way different from kind of the idea of probably what you had going into genomics, but let me tell you that this is probably one of the most important concepts to grasp. And getting good at using regular expressions really lets you do anything. They're kind of like magic. And to be really honest, regular expressions are what sold me on the usefulness of coding. I originally was not interested in coding when I was early in my graduate career, and for some reason, regular expressions kind of sucked me in. It's kind of like a puzzle. So what is or are regular expressions, or regex for short? Well, it's a fancy way of using find and replace, but with a really powerful, flexible search pattern recognition. And so you've actually used really basic examples of this before. If I was to show you this line here, rm star.text, you should by this point know that that star is a wildcard, right? It stands for any and every letter, and then ending in .text. So you'll rm and delete anything that ends in .text in whatever directory you're in if you execute that. So that's kind of an example of a regular expression character. But regular expression can be far more specific and far more flexible as well. So rather than try and start with a complex biological problem to illustrate this, let's do something really simple that I think all of us can understand. So let's say I had a huge collection of pirated movies, and they were organized and named in a very way that makes sense to me. They had the IMDb rating, followed by the name, followed by the year, and then the end of the movie type. What if one day I got a wild hair and I decided, you know what? I don't like sorting them by their IMDb rating. I wish that the year it was produced was in the front and the IMDb rating was at the end. How would you go about doing that? What if you had 500 movies? You couldn't just rename them by hand. That would take forever, and you wouldn't ever end up doing it all. So with regular expressions, though, we can really make this a very trivial task. And so I'm going to jump to the end before I show you how I built this out, because this looks complicated, but once you understand the principles of regular expression, this is actually quite easy to build. If we were to use any number of ways of implementing a regular expression and use this as our search pattern, and this is our replace pattern, we would go from this text here to this text here to this text here. What's great about regular expressions is that they can be used in just about any language. And something that I use to write my code a lot in is actually Sublime Text, which is just a text editor that's really friendly for code. Has built-in regular expression search and replace functionality, and that's one of the reasons why it's a piece of software I ask you guys to download for today. And within it, you can actually apply your regular expressions and the replacement text to actually have this happen here. So here you can see that I have two lines. One matches the pattern and one does not, and all we do is change the one that does match. And so this could be a file that had 50 million lines in it, and it would work just the same. And so in a nutshell, and I'm going to walk through all of these, in a nutshell, regular expressions breaks down to specific wildcards, basically. And here's kind of a little cheat sheet that I found for some of the most basic ones. Slash and a little d represents a numeric. So typically any number. Sometimes it'll be extend a little beyond that as well. Sometimes it'll recognize decimals, depending on the language. A /w stands for any word character, so think letters. And a /s stands for any space, a white space. It could be a tab, it could be a carriage return or a new line. And then the opposite for each of those, or the inverse, saying anything but that type of character, is just a capital version. So a /D is anything but a digit. A /big W is anything but a letter. And a /big S is anything that's not white space. So basically any character. It could be a letter or a number, in other words. And so using these, along with a few other character types, we can do something quite powerful. And so I've got all the different pieces that I'm using here below as I walk through this. And so for right now, I want you to ignore the parentheses in here. We'll talk about what those do in a little bit. But I'm going to slowly build out a search pattern for this. This is how I do this in the real world. I take some representative text of what I want to work on, and I slowly build a pattern that will match it. And so here, to match, let's just try and figure out how to match this first part here, the 8.2. To match the 8.2, well, the pattern here is that it's at the start of the line, and it starts with a digit, a period, and then another digit. Now, because we know how IMDb ratings work, it's always going to be 2 digits separated by a period. And so this right here would match it. And so the way we tell our regular expression that we only want to look for this digit matching, the reason it's not matching any of these numbers here, well, one, they don't have a period in between them, but also because we start it with the at the beginning of a line pattern. So here, this will only match things at the beginning of a line. Here, the symbol for any digit. A period is typically a wildcard. It's actually the same as an asterisk, almost, from what you guys have been working with. But we want to treat it as a real period right now. So anytime that you have a character that has special meaning, you can actually remove its special meaning with a backslash. So a backslash period is just a normal period. And so that's why that pattern matches. So let me show you how this works real quick. Here I am in Sublime Text, and I have that same movie pasted in there. Now, what I like to do as I'm building out small pieces is I like to use incremental find. On Mac, it's Command I to open up incremental find. You can also go up to the find drop down and go to incremental find as well. Now, what's nice about this is it will highlight things as it matches. So you can kind of use this to slowly build out your pattern. So what you can see here is I already have this regular expression thing triggered. If this is unchecked, it will not recognize any regular expression special characters. So always make sure that's checked. So if we go, okay, let's see where all the patterns are for a digit. Okay, so here's a pattern. We've got just a digit. And you can see that, okay, well, there's a pattern match, 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 match. That's not specific enough for us. So let's say we want a digit and it has to be at the start of the line. Well, now we're only matching that one. We know that we want a period and another digit. So that's how I ended up getting there with that pattern match. Okay, so now let's find a pattern that will match the name of the movie. Now this one's a little more complicated because movie names could have letters, they could have numbers, they could be long, they could be short, they could have white space. So we need really kind of a clever way of thinking about a pattern. And this is why working with regular expressions can be fun or frustrating. And so I've identified a pattern here for you. And so again, ignore the parentheses for now. We're going to talk about those. But what this pattern is saying, and we used this format when we looked at pattern searching within the human genome, you can use a stand-in for a wildcard character by using brackets. So remember we did the brackets and then we had the big A or the little a, for example. Well, here we're doing the brackets and we're doing a caret, which stands for except any character within the bracket. So this is like an inverse bracket. So here we're going to look for any character except the opening parenthesis. So if you can think about it, it would actually match all these characters, right? Even these 8.2s if we didn't have other matches already hitting them. And so here this is saying match any character except the opening parenthesis. And so if you've got a movie name with a parenthesis in it, it's going to break this. So that's the one thing you need to be careful about when you make these patterns, is looking for exceptions. And then we don't know how many letters there are going to be in the name of the movie. And so what we do is say repeat the previous match until no more are found. So it's going to look for anything but an opening parenthesis until it gets to something that doesn't fit that pattern, which is the opening parenthesis. And so it would match this part. Technically, it would also match this 8.2, and I'll show you that now. So here we've got that first match. Now, typically we would be building off of this. So we would want to try and now extend it to the Groundhog's Day. So we would go bracket, everything except the opening parenthesis right there, and add a star to it. And so now you can see we're matching everything. If we got rid of these digits here, it would still match because it doesn't have that starting at the beginning of the line. It will even match after that opening parenthesis as well because that fits the pattern. But I'm just trying to show you these small little pieces one at a time because we're going to be moving those pieces around. So this is really how we're going to be building it out as a whole piece. Okay, and now the last part, probably the easiest part. Again, ignore the outer parentheses for right now. Here, parentheses have meaning in regular expressions. So we're going to use that slash to say treat this as a regular old parenthesis. So our pattern is look for a parenthesis. Then you could do /d 4 times like this because we're looking for 4 digits for the year. Or you could say /d with a bracket and a 4 to say repeat that 4 times. I probably would just do this, the /d 4 times, unless I was dealing with something like 20 or 30 something, just because it feels better to me. And then we're going to have a closing parenthesis that we need to use the backslash to escape so it treats as a regular parenthesis. And so now if we go back and tack this on, so our opening parenthesis right there matches. Then we have /d. Now you could do that bracket times 4, or you could actually, if you wanted to, just use the wildcard to extend it till there's no more matches. That's another option as well. And then close the parenthesis. Okay, and we're just about done. All that's left is really the movie extension or the file extension. And this one's relatively easy. So your movies could be .mp4, .avi, .mov, all sorts of things. Rather than try and do something fancy, we know that it's going to be the end of the line. So let's just keep it simple. Again, ignore the parentheses for now. And just put a dot, which is a wildcard for anything except a line break. So it won't go to the next line, thankfully. So wildcard, repeated until no more are found. So basically, anytime you do a dot star, it's just going to finish off your line. So if we do dot star, finishes off the line. We have now successfully really written a pattern that matches this entire thing in a smart way where each of these pieces are individually identified. And we'll show you why that's important. Because if you were lazy and you just wanted to make this all highlight, you could just do dot star from the beginning. But that's not what we want because we want to rearrange things. So let's talk about how to do that. Okay, so just to kind of double check that what we wrote is kind of robust, here's a nice clean movie name, and here is one that is very problematic. But let's see how our pattern actually works with that. So what you can see here is that it's actually selecting both just fine. And let's just walk backwards through it and watch these pieces fall off. So now we're capturing everything except the ending. Now we're capturing everything but the year. And now we're capturing just the IMDb rating. Okay, so let's finally get to these parentheses. So I didn't have these in the ones I was doing live for you. But for each one of those pieces, the IMDb rating, we enclose that in parentheses. The movie name, we enclosed it in parentheses. The date, we enclosed in parentheses, as well as the extension for the movie. Now, why we did this is because every time you do this, each one of these is basically becomes a variable. And so the first one becomes equal to /1. This is now equal to /2, /3, and /4. So if we were to take that whole pattern and replace it with just /1, we would just get the /1 piece. Let me show you how that works. So here, we'll go ahead and put the IMDb rating in parentheses. We'll copy this, and we'll go to find and replace. And so we're finding this whole thing, right? This whole thing is being found, but we're going to replace it with just /1. And so if we replace both occurrences of this, we've gotten rid of everything else at this point. It keeps, you capture whatever's in the parentheses and pass it down here. Okay? You could even do something fancy and say, IMDb rating is /1. And if you replace it that way, now you've actually done something a little more clever. Okay? Okay, and the second one in a row is going to be /2. You could even flip them. You could go /2, then /1 if you wanted to in your output, and it'll flip the name and the IMDb rating. You could add an underscore in between them if you want to be fancy and consistent, whatever you want to do. And so if we really wanted to flip these around, let's just do that. So if we've got these all captured, so we'll add in our parentheses to capture these things. Get the dates and the file extension. What we wanted to do is we wanted, right, to move the IMDb rating, which is going to be /1, to the end. So what we really want, the year in the front, so we want 3 to be in the front, then 2, then 1, then 4. So if we did /3, /2, /1, /4, and we replace these, we fixed it. Now we could do some other things to kind of clean this up and stuff too, but we have successfully flipped these things the way that we wanted to. Now we haven't renamed any files because, you know, we're just working in a text file right now, but that is something we could do. So if you wanted to implement this regular expression we came up with, this pattern, and actually start to manipulate files with it for renaming purposes, we have to deal with a different way of applying them. We can't just do it in a text box. And we often would do this in shell using sed, which is something many people hate to use. And I will say that sed is beyond the scope of this class. If you're just interested in just kind of getting your feet wet with regular expressions, by all means, kind of stop here and go work on today's activity. If you're curious, I'm happy to kind of show you kind of some of the power of sed in the next few minutes. Sed is a way of applying regular expressions within the shell. And so let's say that we have a file here, and we'll call this s.txt, that has 3 lines in it that just have a bunch of words saying out letters and things like that. Well, the format of sed is that it's an S and then a slash, or another delimiter I'll talk about. And then this is your search line here, where the lowercase 1 is, and your replace line is the uppercase. And so notice we have replaced this first lowercase 1 with uppercase 1 by piping through sed. So it just manipulates the output. And so there's 4 parts to any sed command, and they're always going to be in these little single parentheses. The S at the front says that you want to substitute. There's going to be a delimiter, and that's defined by what comes after the S. You could actually replace these with underscores, which is something I like to do. Your search pattern, and then your replace string. And so the reason I like to use underscores is because when you're dealing with particularly directories that already have slashes in them, it starts to look like a picket fence. Whereas if you use underscores, this looks a lot better. It looks like you were taking the search pattern of user local bin and replacing it with /common bin. Okay, and that's a lot more readable than this, and those do the exact same thing. So something you might notice is that when we do this first example of using sed with this simple pattern search and replace, we only replace the first one on this line and not the second one, but we replace the one here and the one here. So by default, unless you tell it otherwise, sed only replaces the first pattern recognition of each line. If you want it to do more than that, you have to make it global. You have to put a G on the very end. I almost always do this. I'm used to putting an S and a G at the beginning and the end of every sed line. Okay, so now it's going to do all of them. So just like the movie example, we can use parentheses to capture things and then use the /1, /2 to replace them. And if you add a -r as an argument at the beginning of sed, you can use all of your basic regular expression patterns like the /w. Okay, so here this is kind of a silly example, but I'm just showing that the functionality is the same. Here we're searching for a pattern to capture where there is an O followed by any letter followed by an E. So really it should match 1, right? And then we want to replace that instance with the whole line of we captured, quote, capture group 1, and we want to make it global. And so I probably should have put a space here, but you can see that this says we captured 1, 2, 3. We captured 1, 2, 3. Okay? So that does exactly what we were hoping. So now all we have to do is take what we already optimized in Sublime Text and now use sed in a clever way to use that same principle to rename our files. So here I've made 3 files that reflect 3 movie names that we want to resort the naming order of. Now, one thing to point out, most flavors of sed, the ones on Ubuntu, for example, for whatever reason, the /d doesn't work. So instead of /d, you have to spend the time and effort to put bracket 0 through 9. So this is exactly the same as /d. It's any character from 0 to 9 digits. It's just kind of a pain. So here what we're doing, we're going to ls our movie directory, which is going to be this output here, and we're going to pipe that output to sed. We're using cat to make it so it appears on separate lines. And we're going to allow sed to use regular expressions. And then we're going to do a substitution where our pattern is capturing a group that has a digit followed by a period followed by a digit, ending our first capture group. Our second capture group is any character other than an opening parenthesis repeated until you can't find anymore. Close capture group. So that's our capture group 2. Open capture group, a opening parenthesis, and then any digit 0 through 9 repeated 4 times, followed by a closing parenthesis, end capture group. That's our capture group 3. And open capture group, any character repeating to the end of the line, close capture group. Now, as I showed you in Sublime, our replace text is going to be /3/2/1/4. We're just flipping the 1 and the 3 groups because we want to move the 9.2 to where the 1992 is and vice versa. And so here, I'm just doing that by itself because we're just manipulating the output of ls. So we're just seeing the output here. We haven't done anything to the files. This is just a good way to see if it's working without being saved. You don't want to accidentally erase everything. So building on what we learned last time about environmental variables, we can actually set complex commands as a variable as well. So I'm going to make a variable called rename and set it equal to this sed command that we just made perfect. So that's our rename variable, is the sed command. And so you can execute a variable as a command if it has a command in it using evaluate. And so here we're going to ls the movies. We're going to cat to put them on one line just like we did before. And just to test evaluate, we're just going to do the same thing we did last time. We're going to evaluate that variable we just did, and the output is going to look exactly like when we did the sed line typed all the way out. So evaluating our sed command variable works just the same. Okay, so hopefully we've got some confidence in that. Here's where we're getting to the point where you have little to no experience in this. We are going to have to use a loop to iterate through each one of the items in this list names. And so we haven't talked about this yet, we will, but we're going to basically go through one at a time, kind of like we did with X arguments, but we're going to do it in a more complicated way now. We're going to go through each one of these, and it could be 3, it could be 1,000,000, it could be 1,000,000,000, it doesn't matter. We're saying for I in to infinity, basically. I is going to be a variable stand-in for each one of the lines in a row until it runs out of rows. And so for each line, it's going to execute this line using the variable I within there reflects the contents of that line. So what it wants to do to each line is make a variable called new name equals echo the variable name, which is the line itself, and then evaluate the sed command. So what this is doing is it is echoing the name of the line and then running the sed on it and actually saving that whole thing as a variable called new name. And then it's going to echo new name because I'm not ready to rename anything yet. This is just kind of a test run. And then the loop is done and it'll go back to the top and continue until it runs out of lines. Okay, so I know that's a lot. I don't expect you to get all that right now. But here's the output from running that. Again, looks like everything we've been doing to this point. So now what we want to do is instead of echoing the new name, we want to move I to new name, basically. That's kind of a fancy way of renaming the original name to the new name. And so here's the same thing. There's our loop. We're going to loop through all these. And instead of echoing them now at the end, we're going to move the variable I, which is the line itself, to the new name, which was just the variable I that has had sed operated on it and saved as a variable new name. And so here you can see the output. This file is being moved to here, this file is moved to here, and this file is moved to here. You could do this with a billion movies and it would work just fine. And so this is the power of using regular expressions. So if you stuck through to this point, I appreciate it. This is, to me, really interesting stuff, but I know is getting probably to the edges of your comfort zone at this point in the class. But I think there's value in just seeing and knowing what kind of possibilities are out there to start thinking about uses.